Welcome to Astro Science Academy, and in this video I'll be showing you guys on how to answer questions based on Newton's laws of motion. So now let's have a look. We got question 2, right? So now let's have a look at this question, right? So on my left hand side we got the question, and then on my right hand side I got my formulas, right? So now let's have a look. So now it says that a 10 kg block is connected to another block of an unknown mass m by a light inextensible string. The blocks are placed on a rough horizontal surface. So now a rough horizontal surface, this indicates that there is friction, right? So they told us a rough horizontal surface, right? That's a key point. So we know automatically on this diagram over here, there is what? There's friction, right? So now when a force of 45 newtons is applied to the 10 kg at an angle of 30 degrees to the horizontal, as shown in the sketch below, the blocks accelerate 2.5 meters per second squared to the left. So now we're going to take this direction of the motion to be what? To be positive, right? Because that's the direction of the motion, because the blocks are moving to the left. So you're going to take every force that's going to the left to be what? Positive, because they told us already. This is moving to the left, the entire system, right? Also, now they're telling us the blocks accelerate at 2.5 meters per second squared. This is the acceleration, your A, right? So now the acceleration of the 10 kg block is the same as the acceleration of m. So if the 10 kg block is moving at 2.5 meters per second squared, that means m also is moving at 2.5 meters per second squared, right? So now let's have a look at over here now. Now they say the block of mass m kg experiences a constant frictional force of magnitude 1 Newton whilst moving, right? So now they're telling us 2.1, draw a labeled free body diagram indicating all forces acting on the 10 kg block while it's accelerating, right? So now let's get quickly our force diagram over here, right? So we're going to put a dot over here. So on the question paper I'll advise you guys to do this. So now since this is on the surface, we are going to be getting a normal force, right? So this will be our normal force, right? And also over here this will be our what? Our Fg. So this is Fg, normal force, and over here, so this is the tension in the string, so we're going to call this T, and this is force, right? And also we're going to add friction, right? So we're going to make it a little bit small over here, friction. And remember, friction opposes the motion. Since this block is moving in this direction, that means friction will do what? Will oppose the motion. Friction always opposes the motion. Friction does not support the motion, right? So now that's this free body diagram is for the 10 kg block. Now the free body diagram for block M over here, you're going to have a what? Normal force, right? Also put a dot over here. We're also going to be having, all right, let's erase that. Okay, let's go back. Right, we're also going to be having Fg, right? Fg, and also we're going to be having what? Frictional force, right? So we got this. Now let's write it over here now. So now for question 2, now I can take it out. Question 2, got that. So now 2.1, so now free body diagram for the 10 kg block. 10 kg block, we're going to be having, you're going to put a dot, right? And then you're going to go Fg, right? So please use a ruler over here, right? So now you're going to be having, right, so there's our Fg, and then you're going to be having our normal force, right? So and then you're going to be having the force applied at a certain angle, right? And then you're going to be having tension in the string, and then you're going to be having frictional force. So this is our frictional force. So this is frictional force, this is normal force, this is tension in the string, this is Fg, and we can call that force applied, right? So now you also need to draw a free body diagram for block M. Even though they didn't ask, you're gonna need this for your calculations, so I'll advise you to put it on the side always, right? So now free body diagram for M block, right? MKG, right? So now over here we're going to be having dot, and then we're gonna be having Fg, right, and then normal force, right, and then tension in the string, right. So this is tension, this is normal force, and then you're gonna be having frictional force. So remember, friction always make it a little bit small, right? So now they say the block of mass m experiences a constant frictional force of magnitude of 1 Newton while moving. So now we know over here it's 1 Newtons, right? So now, as you can see, for the 10 kg block, it had 5 marks allocation. So meaning that you should be having 5 forces. So as you can see, we had 1, 2, 3, 4, 5. So 5 marks, right? So that's the trick. So now let's move on. Now they said define the term normal force, right? So now normal force, we know what definitions, right? Because we know normal force, we can say normal force is the force which a surface exerts on an object with which is in contact, right? I'll explain this, right? And which is perpendicular to the surface. So now let's get this right. So now we know a normal force is a force which a surface exerts on an object, right? So now as you can see over here, right, so we got our normal force, right? So this normal force exerts on what? On an object. So there's our object over here, right? So now, which is in contact. So in order for you to have a normal force, the object needs to be in contact with the surface. So if the object is not in contact with the surface, you won't get a normal force, right? And also remember that normal force is always perpendicular, meaning that the force should have 90 degrees, like this over here. You see that over here it should be what? 90 degrees, right, to the surface, always, right? So that's the definition of what? Of the normal force. So remember two things about normal force. A normal force should be in contact with the surface and should be 90 degrees to the surface. That's it, right? So now let's move on. So now 2.3, right? So now they're saying 2.3, calculate the magnitude of the normal force with normal force acting on a 10 kg block. So now, right, over here, as you can see, normal force is not equal to Fg. It's not equal to Fg because we have this force applied at an angle, right? So we need to resolve this force applied, right? So to its component. So now we're going to resolve this right here, right? So now we're going to have Fa cos theta, right? And then we're going to resolve this up here also to its component, and then we're going to have Fa sine theta, right? So now when you hear now, you are just going to consider the vertical forces over here. So you got 3 vertical forces over here. These are your 3 vertical forces: normal force, Fa sine theta, and Fg. And then you are going to say, the sum of all forces going upwards, right, will be equal to the sum of all forces going downwards. So now upwards there are 2 forces, and over here you're going to take all of them to be positive, right? 2 forces are going upwards, which is normal force plus Fa sine theta, right? Which will be equal to what? The force that's going downwards is what? Fg. So now you're going to put this to be down, Fg. And then now remember we're looking for normal force. So now normal force plus Fa, we have Fa, which is what over here? 45. So now you're going to say 45, right, sine, and the theta, the angle over here is what? 30. So here it's supposed to be 30, right? 30 is equal to Fg, and we know Fg is equal to mg, right? We know Fg is equal to mg. So mass is 10, and the acceleration due to gravity is 9,8. Right, so now you're gonna have n plus, now let's take our calculator. Now we have 45 sine 30, right? And that is going to give us 45 over 2, which is 22,5. 22,5, which is equal to, now this will be just 98, right? So now let's transpose this that side. Now n will be equal to 98 minus 22,5. So now normal force is equal to, so now this will be 98 minus 22,5, and final answer will be 75,5 newtons, and that is our final answer, and it's easy as that, right? So let's move on. So now they're saying, now over here, the coefficient of kinetic friction, which is can be referred to mu k, right? Which can be referred to mu k, between the 10 kg block and the surface is 0,125. Now calculate the unknown mass m. So for 6 marks, right? So over here, this will be easy, right? So we can start with the informations on the 10 kg block, right? We can start with that. So now over here, let's work with our free body diagrams, right? Because everything is on our free body diagrams. So now when you're working, let's start with the 10 kg block, because we're looking for the mass m this side, right? And mass m over here, we need to know this value tension, right? Because we know F net is equal to ma, right? And also this side, F net is equal to ma. So now let's start working this side, right, with the 10 kg block. So now we're going to say F net is equal to ma. So now F net, which forces are we going to take? You are going to consider horizontal forces, right? You are going to consider horizontal forces. Right? So now, as you can see, we're going to take all the forces that are going this side to be what? Positive, right? We're going to consider that to be positive because we spoke about that, right? We spoke about that up here, right? Going to the left to be positive. So now we're going to say F A cos theta plus, open bracket, negative t plus negative ff is equal to what? ma. But now, before we go further, right, they gave us the coefficient of friction for the 10 kg block. That means we can be able to get what? Our friction. So now you can say Fk is equal to mu k times normal force. So now frictional force, mu k is 0,125, and the normal force, which we calculated over here, we can say that to be 75,5. So this is 2.4, right? So now let's work with that. So now we're going to say 0,125 times 75,5, and our final answer will be 9,4375, right? 9,4375 newtons. Now let's work out. So now Fa is 45, right? Cos 30 minus tension minus 9,4375 is equal to mass, which is 10, and acceleration is 2,5, right? So we got that, right? So now let's simplify this. So now over here we can have 45 cos 30, close bracket, right, minus 9,4375, right? And that will give us, so let's take at least 4 decimal points over here because this is not a final answer. We're going to say 29,533 6, right? Minus tension is equal to 25, right? So now you just take tension this side and bring the 25 this side. So now you'll have 29,5336 minus 25 is equal to tension, right? So now you're going to say that minus 25, and our final answer is 4, for tension. So now tension is equal to 4,5336 newtons, right? So now we got this tension, right? So now this tension is the one on this side, right? It's the tension here, right? We got this to be 4,5336. Now this will be the same tension over here to be the same 5,336. So now let's work over here now, right? Because we're looking for mass M. So now we're going to say F net is equal to MA, right? So now we're over here now. What do we have? All the forces are going to this side. We're going to take them to be positive. So now tension here is going to be tension plus negative frictional force is equal to mass times acceleration, right? So now tension is 4,5336 minus frictional force, which is 1, is equal to mass, which is what we're looking for, acceleration, which is 2,5. Now this is going to give you 3,5336 is equal to mass, open bracket, 2,5, close bracket. Now divide that by 2,5. Now divide that by 2,5. Now that and that cancels out, right? So now mass will be equal to, now let's calculate that. So 3,5336 all over 2,5, and that will give us, which will give us 1,41 kgs. Yeah, this is mass, and please don't forget your SI unit. And this will be our final answer, right? So guys, for Newton's laws, the most important thing is your free body diagrams. These are very, very important. As you can see how I did my workings, it all depends on my free body diagrams. My free body diagrams will help you answer all these questions, right? So we're gonna stop here for today. Thank you guys for attending, and I'll catch you guys next time. Take care.